was like or may have been like, so we can hypothesize because nobody was there, of course. We know that planets are hot when they form. They release volatiles. These are elements like, or molecules like water, methane, ammonia, hydrogen, very highly reactive materials. They get released from their interior when the interior is heated and melted. The water can condense if there's an atmosphere with the right temperature and pressure, like the Earth has. And we think the oceans formed very early in Earth's history, probably as early as they could when the planet cooled. So our oceans are likely to be ancient. Ammonia and many other phases dissolve in the water and come out of the atmosphere, and the result is this highly reducing atmosphere, heavy in hydrogen, methane and hydrogen, reducing environment. Little, if any, free oxygen. Okay? That's likely to be what the early Earth atmosphere is like, and it turns out to be pretty much like what the atmosphere of Saturn's moon Titan is like, which is why we care a lot about that. And you can actually simulate this environment in the lab, and those experiments have been done going back to the 50s, famous Miller-Urey experiment in the 50s, where they took that mixture of methane and ammonia and hydrogen, put it into a flask, put some water in, pretended it was a primitive ocean, cycled the water through, sparked it with some electrodes, pretended that was lightning, energy sources, so liquid water, energy sources, organic molecules, and the result was that the flask got very brown and gooey very quickly and got coated with complex organic molecules, simple amino acids, and life's building blocks. And this is often called primordial soup. So it's not hard. It's actually not hard. Relatively simple natural processes on a planetary surface or inside of a molecular cloud where there's energy sources and organic molecules and water vapor in that environment and other reducing gases to make this material. So the experiment's been redone many, many times, and no one has ever made anything alive in there, but you can make the building blocks again and again and again. So it's not a hard thing to do. Okay? Maybe they're simple experiments, but they demonstrate that the interaction of these components, energy, water, organic molecules, can produce more complex organic molecules, more and more complex as you increase the energy and the time of the experiment. It's not an efficient process, but even if we didn't make enough organic molecules in that process, they're being made elsewhere and they're being delivered to us by asteroids and comets smashing into our planet, especially early in history. And so building blocks of life are abundant in the cosmos, and the question really is, how did they become alive? How did that happen?